So I think now we're going to move into a presentation from another partner of ours in the Tridion ecosystem, and that's the partner Accelerate. So the team presenting from Accelerate will be doing it live here, and that's we've got Frank and Dimitri. Frank is a senior architect over at Accelerate, I think based in the US. Principal architect. Do I have that right, Frank?
Principal, and you can throw in whatever words you want after.
All right.
Consultant, architect, developer, that works.
Sounds good. So these guys are going to talk a bit about kind of going back to the database world and NoSQL, MonGo, and where that fits into the Tridion ecosystem. So I think we're moving slightly away from the taxonomy focus, but into something that I still think is super valuable and you guys will get a lot out of. So Frank, I'll let you take it away.
Great, thank you. So the first thing that I just want to say is that I appreciate everyone that's here, because I know that if this were a real live event, it'd be super exciting because our boss would have reimbursed us for flying out to San Francisco or wherever. And if someone's actually tuning in online, that means that you really meant to, even though it wasn't getting reimbursed. So I appreciate it. So with that said, our presentation is MonGo or MonGone, NoSQL's usefulness in Tridion ecosystems. And before we get started into the presentation, we've already gotten a little bit of an introduction, but I'll introduce myself, Principal Solutions Consultant and Woodworker. And I have experience doing front-end development for content management systems. And Dimitri, would you like to introduce yourself?
Yeah, thank you, Frank. And thanks everyone for tuning in. My name is Dimitri, and I'm a software developer and a gamer. I have experience in both fields, and most of my work is based on CMS applications and mostly on content management side. Take it away, Frank.
Thanks. So we have a few goals here that are pretty straightforward. The first thing that we want to do, and what's been really interesting watching the other presentations, is that I feel like the argument has already been made, but I guess I'm just reinforcing it at the end, that content is relational and that it's relational regardless of your tech stack. We also want to share with you that there are challenges of working against the grain of relational content. And I recognize that's a little bit of a woodworking term. If you've never cut a board or tried to thin one down, there are ramifications for not working with something the way that it wants to be worked with. And we want to share what some of our experiences have been there. And the final thing that we want to do is show you how to actually work with relational content in a way that works for you regardless of your tech stack. So with those goals in mind, let's first talk about the fact that content is relational. And again, other people have already reinforced this, but I'd like to present this from the perspective of our clients. The first is one that you can see on our own homepage, where if you were to go to accelerate.com, you could look at our case studies and you would see that, okay, well, these different content items are related. They're related because they have the same content type, which we would call a schema in Tridion, or a content model more generically. Well, they're related because they have, well, metadata and taxonomy. They have things that are grouping them together because they're case studies about Tridion. You could also, by the way, say that they're related because, well, they have the same container. They're in the same page. And we could also relate them by the fact that they have this same template. They're being presented the same way. But if you were to look at another one of our clients, at one of Essity's properties, you'd see a press releases page. And here again, we see content items that are related, but we'd say that really they're related because of attributes, this metadata or taxonomy that we've been hearing from Joseph. And you'd also be able to say that, well, they're related by certain fields in the content, like year, month, or topic. So those are just two ways that content can be related to other pieces of content. One comes from a design perspective, from the person that's designed the content management system. Another kind of relationship comes from the content side when we're looking at specific fields, but there's yet another way that content is relational. If we were to look at Kaiser Permanente's regional landing page, we're going to see content that's related And when we look at things like an introduction or self-education and decision-making content, and even those alerts that you might see, well, those are relationships that actually stand out to the end user. Maybe or maybe not are these relationships being managed in the content management system, but they exist because the end user is going to look at them, and maybe it's because of how the content is written, maybe it's because of the design of the page. Regardless, the end user is going to see, oh, these content items are related, and that's what puts together the cohesiveness of that page. So we can see from just 3 small examples that content is relational. Content items are related to each other. Sometimes that's by design. Sometimes that's by the nature of how we're going to put content items together in a group, and sometimes that's by user perception. So the fact that content is relational actually matters because, again, that content is relational and it has nothing to do with what we've done to that content. We'd like to think it, but content is relational regardless of us trying to put those relationships together. What's important is that we recognize that content is always going to be relational. So, okay, neat, content's relational. What do we do with that? What does this have to do with Tridion? Well, Tridion already captures some content relations. And some of these, if you're familiar with the Tridion ecosystem, might sound familiar. We have a schema that can create components. We have components that can live in a page, and pages can go into structure groups, and then we have folders, and then we have categories and keywords, and then we can associate categories and keywords all over. And really what we find when we evaluate Tridion is that Tridion actually does an amazing job at forming all of the various content relationships that can exist between items. And what's really neat about what Tridion does is that it captures relationships not just between 2 units of content, but between organizational systems for content as well. And if you're not sure what I'm talking about structure groups and folders. The fact that we can put the same keyword on a component, which is a single unit of content, and then also put that keyword on a folder, well, that means that we're able to create a relationship between a unit of content and the thing that organizes it. And if we can put that same keyword on a page and on a structure group, well, now we can actually create relationships between not only one content item to another, but one organizational system to another. So that's really fascinating that Tridion gives us all of these ways of establishing content relationships. And that becomes really important as we start talking more about relations. And so now we have to ask this question of, well, okay, how does Tridion capture content relations? I asked a few different folks, how does Tridion take a relationship between 2 content items and then expose it? And the most common answer that I got was, well, it can publish pages. And that's true, that if you put 2 components on a page, they have a relationship. And when you publish that page, then, okay, you've exposed a relationship. But what about all those things that we just talked about? What about those organizational systems? What about how structure groups could possibly be related to components, or folders could be related to whole publications for that matter? How does Tridion deliver those? Well, here's the thing. Tridion stores that information. It stores it in SQL databases. That CM database, that content management database, it has all of those relationships. But how do we get them out? And then how do we publish those relationships? And here's the thing, not every application that we have, not every project that we have requires us to expose this information. But especially in large enterprise clients, they may have extremely complex business rules and applications that really require us to put things together in very creative ways. So this brings us into this question now that we're presenting. Does MongoDB help or hurt in this case? And it's an important question to ask because MongoDB advertises itself as a NoSQL database. That means that it's not keen on being relational. So if content is relational, what is Mongo's role in that for Tridion? And so I'm a consultant. And because I'm a consultant, I get paid lots of money to never give you a straight answer. If I did that, I'd be out of a job. So I have to give you a long and complex answer to the question of, does MongoDB help? And just say, it depends. MongoDB is great if you have schemaless data. If you're not concerned with the structure, if it's okay that something can be a number one day and a string at another, or if you want to add extra fields, Mongo is great for that. But something to consider is that Mongo is it's a document database. Its goal is to store whole chunks of content. And I'm trying to be intentional about using that word content rather than data, because that's what Mongo will tell you that they want you to use it for. On their own website, they will tell you that the relational approach is a distraction. It detracts from developer productivity rather than improve it. And that's an important thing because, first of all, they're right. It is a distraction when you're a developer and I've got a page with 5 different things that are somehow related and I have to make all these requests to figure out how they're related. That is a distraction. It would be better if I could get all of that data at once. And that's fine as long as I'm getting a final finished product and I don't need to start associating anything else with it. That's helpful. When I need to request documents, Mongo is a great document database. But what if I still have some work to do? What if that document is just a piece of the page? What if there's other things I still have to add? And what if I have to put together my entire navigation system based on these items? What if these relations just keep spreading too? That's where we start to run into a question about this, because MongoDB, again, will tell us data that is accessed together is stored together. So they basically justify their database in saying that just put it all together. As long as it's all together, you're fine. And that's a great approach, so long as your data is together. But what if it isn't? What if there's other things that need to be associated on your page? What if you're building a very complex single page application that has many different content items and associations between those items, and you have many different kinds of personalization? Well, all of a sudden, you just can't put together one giant document that has all of those things. You're going to have things that are broken apart, and this is where MongoDB can hurt. If you can't put all of your data together, everything's not going to be so easy. And we encountered this with a client. We had a client where what they were doing was taking their content that was associated in a variety of very unique and creative ways. They were associating keywords to pages, to components, to folders sometimes. They were putting things together in ways that made sense for how they did business. They were very complex relationships. And so they wanted to serve this in a headless model. And what they were doing was using Tridion to publish a page, and that page would have some templating logic that would look up different references that might have been implicit. And that's something that we learned about from Andreas, that sometimes you can have some missing links, or sometimes there's implicit semantics. This was actually a case here where that happened. There were missing relationships that weren't quite established in Tridion, but they were implied by the use of a taxonomy item. Regardless, Tridion is publishing a full XML file that goes to a file system, and then we have a Node.js application on the other end that's running on a cron schedule, which means that it's just running on a schedule. And about every hour, it scans the file system, finds that XML file, does some additional lookups, and it goes and finds other XML files, and then puts them together into a document to go into the database. And then on the other side of that, we had a REST API that's putting together more of these documents and delivering that to a single page application. So what we ended up with was 3 different application layers that are all trying to establish relationships between kinds of content. And in the middle of all this was MongoDB, which was only storing documents, and they weren't the final documents. So this is where we realized we were getting hurt. What was flowing from one application to another, the relationships were getting watered down, and we were losing more and more of them. And that became very, very difficult for our developers at each layer, because they're then having to reconstruct these relationships, and they're doing so in a very manual way. When all the while, Tridion is over here, and it knows exactly how all of these different items and pages are put together. So we were getting hurt in this case by trying to fit a non-relational model into highly, highly relational content. And we all got involved in this because we were trying to speed up publishing, because publishing wasn't on demand, it was on a schedule. That meant it took things a while to get out the door. And our initial thought was, well, what if we just published to MongoDB? This would be great. And as we kept exploring that and working with the front-end team to sort out exactly what we would publish to MongoDB, they kept on insisting that we resolve all of these different content relationships. And we kept on telling them, but we don't want to. We just want to give you all the data. And they said, but we need all these things resolved for us. And we said, but you can resolve that. And one of the front-end developers actually identified the problem perfectly. He said, we don't have a relationship problem, we have a graph problem. And if we've been watching the other lectures that we've seen so far, we've been hearing that word graph quite a bit. We discovered with our client that we had a graph problem. And it's sometimes hard to know when you have a graph problem, but one thing to keep in mind is that they aren't always obvious, and sometimes technologies are going to cover up the fact that you've got one. Because if a technology doesn't support multi-model relationships, well, then it doesn't support them, and you end up building applications to try to squeeze that back in. That's that going against the grain. And when you've got multiple technologies trying to solve the issue, you don't realize you've got a graph problem, except you realize that you've got 3 different applications all trying to solve a graph problem. And if you're looking for a handy way to know, like, do I have a relationship problem or a graph problem? Once you're talking about a connection to a connection to another connection, well, that's a graph problem. It's an easy way to solve it, or recognize it, I should say. So once we realized that we had a graph problem, we realized, okay, we need to solve it. But we didn't want to spend a lot of time trying to solve this if it could be too complex. So we wanted to do a POC. So we took some ideas from this book, Sprint, by these Google venture guys that basically have this idea of do a 5-day sprint, and that's it. That's your prototype. So we decided to do that. We decided, let's build a GraphQL API on the Tridion broker database in 5 days, and see if we can do it, and see if we can prove that there is a graph problem and that we know how to solve it. And all I can say is, if you're going to POC, set the bar as low as you can. That way you can be successful. You're always successful if you lower the bar enough. And that's what we did, and we were hugely successful. And at that point, though, this is where we need to get technical. And so I want to pass this over to Dimitri, and I'd like for him to talk about the technical side of this solution.
Thank you, Frank. Let's talk about how we did it. So we developed the API in the C#.NET technology. We also used the hot chocolate libraries from Chili Cream Fellas. We went with RepoDB as ORM, and in that way we managed to create a successful GraphQL API. All that was wrapped inside an Azure function so that we try to get on-demand data. And there's a few things that I would like to point out before going directly to the code and looking at the pictures. We used the annotation-based approach of developing the GraphQL API. And also there's a lot of things that Hot Chocolate hides from us, which makes the implementation a lot easier. And those folks were mostly focusing on the performance. So let's get into the code. Defining models is really important in the GraphQL API development because by defining models, we define object types. And object types are the most important part of any GraphQL. And in that way, if we want to make them intuitive, we need to make them clear, to make them understandable, so that every party which needs to retrieve some data knows what's at their disposal once they look at the class or the documentation of the class. So you can see that we use the map attribute to map the class to the DBO page table. And we use the map attribute as well for mapping the table attributes. And when doing that, Hot Chocolate resolves the names, compiles them, and we get everything delivered. So we use models for the resolvers. And resolvers are also part of a query. They're nothing more than a generic function which can or may not retrieve any arguments. And we use resolvers to define how we want to fetch the data. Also, resolvers, as they are part of queries, and we developed a read-only GraphQL API. So the only operation we needed was the query. And by doing the extending object of the root named query, we then deliver the dynamic field of the page object type. So this is how we defined a simple schema in GraphQL. But what if there are relations between multiple tables? And for that, we're going to look into first, what are data loaders and why are they useful? So if we have, for example, a page object type and a page content object type from the page content table, they're linked by the reference IDs. And every time we would like to retrieve a page content for a certain page, we would need to create a query for every page request. But data loaders make our life easier and they conserve time. By just gathering all the requests that they want to retrieve the page content from, they gather all the IDs and then create a single batch query and return us all the objects, all the entities from the database that are in the requirement spec. So we use the dictionary object for retrieving data instead of our repository service. And so in conjunction with the resolver, as we can see from the next page, we now use, and Hot Chocolate knows when to inject by defining the attribute data loader and then providing the name of the data loader, or rather the type. We can then extract all the data we need once the GraphQL API starts to resolve the request. We then can just arrange a request from the data loader instead of the service, we then don't have a n+1 problem. We just have a in-memory retrieval of the data. And you can see at the top, we extended the object page and not the root. And that's because the page content object type is a part of the page. And once we request the page content from the page, once it gets to the page content field, it resolves from the parent page. And that's why we can reference it by the parent's ID. So let's talk about how we put all those modules together and how we make it run. We started by initializing the RepoDB bootstrap and then retrieving the service object, which will hold all the services needed for our application to run. Adding some custom services, for example, our Tridion repository service, so that we can retrieve all the database entities. And of course, the most important part is adding the GraphQL and all of the services and queries we need for resolving our requests. Also, there is also possibility for configuration to our heart's intents. For example, we can see here that we are setting a paging option to retrieve however we want. But the GraphQL by its own, it can't retrieve the data if there's no demand for it, if there's no schedule to tell it when to retrieve it. So for that, we need to communicate it. And with that, we can use Tridion. Tridion has all sorts of mechanisms to communicate with external microservices, APIs, endpoints, and so on. There's the approach we took, and that's by creating a storage extension where I created a contract, which is nothing more than describing the publishing action. And when published is triggered, we tell an Apache HTTP client to notify the GraphQL that something happened. We can provide as much data as we want, and then let the GraphQL do its thing, parse it, take the data, create its own requests. Or we can do that by extending the event system, and on publish success, we can then trigger also a request to the GraphQL API and tell it that something happened. There's also a third possibility, which is outside of the scope of this presentation, that would be the GraphQL subscription model, but that's present on the Hot Chocolate documentation. That's all for me.
Great.
Back to you, Frank.
Thanks, Dimitri. So we set out to do a 5-day POC, and we managed I should point out, in Tridion 8.5 to create a GraphQL client running in .NET Core inside of an Azure function that we actually, if we wanted, we could have gotten so far to even deploy it to the cloud. We didn't. But we were able to pull it off because all of the tools are already out there. We just had to put them together in the right order. And what was great about committing to only 5 days, again, is that we could use as much code and make it as ugly as we wanted because we just wanted to see if we could provide relational content. And we were. And our client was really happy to see that that we both understood their problem, that it was a graph problem, not a relational problem, and that we could come up with a solution that could deploy anywhere. So with that, a few final thoughts, because we kind of would like to put that all together. Keep in mind that content is always relational. The tech stack doesn't make a difference. Content is related, and it's always best to just work with the grain of relational content. What we found in this exploration process was that NoSQL doesn't work at least for this client, NoSQL was not helpful. We needed more than just a SQL database. We needed a graph database or a graph API to help us. But also something to keep in mind is that not every content relation problem is a graph problem. But if you think it is, and you think you need a GraphQL client, POC fast. Don't spend more than 5 days on it. And GraphQL is easy, in theory, with the right tools, which is to say, it's a copy pasta, as we sometimes call it. It's totally fine here.